Welcome to add-on. In this question, we are asked, what will be the addition of these two octal numbers 675 with a base of 8 and 764 with a base of 8? Okay, so let's start with the solution, right? So the two numbers which are given to us are 675 with a base of 8 and 764 with a base of 8, and we need to add these two numbers together. So for the sake of the simplicity of this solution, we are converting these two octal numbers into decimal numbers, right? So from 675 we will getting some decimal number with a base of 10, and then from 764 we will get some decimal number with a base of 10. Then we will add those two decimal numbers together because addition in decimal is quite simpler. Then we will get a resultant decimal number, and then from the resultant decimal number we will convert it into octal number. Okay, so let's start with the solution. So for converting this 675 into its decimal equivalent, we need to multiply each of the digits in the octal number with its positional weights. Now, by positional weights, I am meaning, suppose this is 675. So at the right hand side, the bit which is present at the absolute right hand side is the least significant bit, and the bit which is present in the absolute left hand side will be the most significant bit. Okay, so the right hand side is the least significant bit and the left hand side will be the most significant bit. So the positional weight of this will start like this. At the least significant bit we will have a positional weight of 8 to the power 0. Then for the next bit to the left we will get a positional weight of 8 to the power 1, and then to the next bit on the further left hand side, which is the absolute left hand side of our octal number, we will get a positional weight of 8 to the power 2. And if the number is more lengthy, suppose we have some more digits in the left hand side, then the positional weights will increase simultaneously with 8 to the power 3, 8 to the power 4 likewise. So now to convert this octal number into its decimal equivalent, we need to multiply this positional weights with this signal with its respective digits. For example, 8 to the power 2 should be multiplied with 6, 8 to the power 1 should be multiplied with 7, and 8 to the power 0 should be multiplied with 5. And then we need to add those multiplied numbers together to get our equivalent decimal number. So let's start with the process. We will do 6 into 8 to the power 2 plus 7 into 8 to the power 1 plus 5 into 8 to the power 0. So if we do the 8 to the power 2 is 64, 8 to the power 1 is 1, 8 to the power 0 is 1, and sorry, my mistake, 8 to the power 1 is 8, 8 to the power 0 is 1. So if we perform the addition together, we will get a result of 445. So here we are getting 445. Similarly, we will do this uh, conversion process for this octal number 2. So here we will get simultaneously 7 into 8 to the power 2 because it is the most significant bit, and as these two numbers are equal in length, this positional weight will remain the same, only this digits will change. So we will get 7 into 8 to the power 2 plus 6 into 8 to the power 1 plus 4 into 8 to the power 0. Okay, so 8 to the power 2 will be 64, 8 to the power 1 will be 8, and 8 to the power 0 will be 1. So if we perform the addition, we will get 500. So here we are getting 500, and if we add these two together, we will get easily that the result will be 945. Now to convert this decimal number into octal number, we have to divide this decimal number with the radix of octal number, which is 8. Okay, and after each division we have to keep the track of the remainder, and then we will divide the quotient. Suppose uh, the decimal number which is given here is 945, which we are getting from the addition. So first we are dividing 945 by 8. Okay, 945 by 8, which will give us what? Which will give us 118 with a remainder of 1. Okay, with a remainder of 1. Then again we have to divide this quotient. This is our quotient, so we have to divide this quotient again by 8. Okay, so we will divide 118 again by 8, which will give us uh, 14 with a remainder of 6. Then we again need to divide the quotient by 8, 14 by 8, which will give us 1 with a remainder of 6. Now we will divide again 1 by 8. So we will get 1, if we divide it by 8, we will get a 0 with a remainder of 1. Okay, so now the division is not possible further because we have received 0 on the quotient. So one thing that must be noted, that we will continue the division process up to the point we are getting 0 as the quotient, and as soon as we get 0 as the quotient, we will stop the division process there, and we will keep the track of the remainders, and we will write the remainder in bottom to top approach, in this direction, bottom to top approach. So first we will write 1, then we will write 6, then we will write 6, then we will write 1. So our number will be 1661, and as it is an octal number, we will write base of 8. So our resultant octal number will be 1661 with a base of 8. Thank you.